নমস্কার সবাইকে। আজকে আমি চলে গেছিলাম ইন্টারন্যাশনাল কনফারেন্স অন ডেটা ম্যানেজমেন্ট অ্যানালিটিক্স অ্যান্ড ইনোভেশনে ICDMAI 2026, যেটা চলছে সেন্ট জেভিয়ার্স কলেজে 9 থেকে 11 জানুয়ারি 2026। এখানে বিভিন্ন জায়গা থেকে আমাদের যারা ডেটা সায়েন্টিস্টরা রয়েছেন এবং যারা আর্টিফিশিয়াল ইন্টেলিজেন্সের উপরে কাজ করছেন, রিসার্চ করছেন, তারা এসেছেন ব্যাপারটা কীভাবে চলছে সব কিছু তার উপরে আমাদেরকে একটা নলেজ দিতে। হোয়ার ইনোভেশন মিটস ডেটা সায়েন্স। ওকে, ICDMAI 2026 brings together leading experts from computer science, information technology and related disciplines to explore cutting-edge developments in data management and analytics. Discover how cloud computing, real-time technology and big data platforms are transforming business operations and driving enterprise innovation in the digital age. This is organized by Society for Data Science, which means S for DS. This premier event connects global innovators and researchers. তো আমি গেছিলাম আজকে 10 তারিখে 10ই জানুয়ারি 2026 সকালবেলাতে পার্ক স্ট্রিট থেকে উদ্দেশ্য ছিল এইখানে যাওয়ার। তো রাস্তায় যেতে যেতে একটুখানি ভিডিও করে নিচ্ছিলাম। আজকে শনিবারের দিন, সকাল সকাল পার্ক স্ট্রিটে অত ভিড়ভাট্টা নেই, একটুখানি ফাঁকাই রয়েছে। তো ভাবলাম চলি একটু ভিডিও করেই নিই, আপনাদেরকে একটু দেখাই। তো চলুন আমার সাথে সেন্ট জেভিয়ার্স কলেজে। আমাদের যেতে যেতে প্রায় 11টা মতো হয়ে গেছিলো, একটু দেরি হয়ে গেছিলো। কারণ এই কলকাতার রাস্তাতে ওলা উবের বুক করে যাওয়া, বারবার ক্যান্সেল হয়ে যাওয়া, তারপর আবার বুকিং করা বড্ড প্যাথেটিক ব্যাপার হয়ে উঠেছে। সকালের পার্ক স্ট্রিট একরকম আর সন্ধ্যেবেলার পর থেকে পার্ক স্ট্রিট আরেক রকম। তো আপাতত চলে এসেছি সেন্ট জেভিয়ারের রাস্তায়। আপনারা রাস্তাটা দেখলে বুঝতে পারবেন কত সুন্দর। এই দেখুন পার্ক স্ট্রিট, পুরনো আমলের সমস্ত বাড়ি। আজকে রয়েছে এখানে সারা দিনের প্রোগ্রাম, দুপুরের লাঞ্চ থেকে শুরু করে বিকেলের স্ন্যাক্স, তার মাঝে তো নলেজ গ্যাদারিং। জানি না কতটা কি বুঝতে পারবো, বাট শুনেও যদি কিছু ইন ফিউচার সেটাকে ইমপ্লিমেন্টেশন করা যায়। আর এত বড় বড় সমস্ত রিসার্চাররা যারা এসেছেন, ওনাদেরকে দেখতে পাওয়াও একটা খুব সান্নিধ্য লাভ করা আর কি জীবনে। এই রাস্তা হচ্ছে পুরো নস্টালজিক রাস্তা। ওই দূরে গেট দেখা যাচ্ছে, চলুন। এই দেখুন সামনে অলরেডি একটা ব্যানার দেওয়া রয়েছে ডান সাইডে। সেন্ট জেভিয়ার্সের গেটে পৌঁছে গেলাম। লেখা রয়েছে ওয়েলকাম টু ICDMAI 2026। ঢুকবো এবারে। এখানে অডিটোরিয়ামে এটা আজকে চলছে আর কি। মিস্টার প্রসূনকান্তি কর, TCS এর ফেসিলিটি ম্যানেজার, যার দৌলতে আজকে সেন্ট জেভিয়ার্সে ICDMAI সেমিনারে আসা। AI এর উপর আজকের সেমিনার। স্যার হাই করে দিন।
হাই।
এটা হচ্ছে শাইনি, এও TCS জব করে, এর সাথে এসেছি। হ্যাঁ আমি আছি, আমি আর ক্যামেরার সামনে এলাম না। এখানে আপনারা দেখতে পাচ্ছেন প্রফেসর শঙ্করমিত্র বন্দ্যোপাধ্যায়, যিনি আসবেন আর্টিফিশিয়াল ইন্টেলিজেন্সের উপরে কিছু রিসার্চ পেপার সম্পর্কে জানাতে।
Of the healthcare related work that we've been doing. I don't have slides so that in this lecture we will just a half an hour talk, so I thought I'll just do a general overview. And before I start, I would like to thank Dr. Mitro that it was a very, what should I say, a very introduction. I'm overwhelmed the way that you introduced me. I've been doing my job, and whatever happened has happened on the way. So the only thing is I've tried to be true to my job. That is all. Did what I could do to the best of my abilities. And to the young students here, this is a message that I would like to share with you, that I have never had any particular ambition, but my only thing was whatever I'm doing, I'll do it to the best of my ability. And then everything else will take over, wherever life leads me. But if life leads you to a very good opportunity, do not miss it. You must go to the best institute that your effort leads you to, because best institutes will mold your thoughts in ways which you may not imagine. So, and that happened in my journey also. I went to one of the best institutes in India, some of the best institutes in India, and that has helped me quite a bit in developing my persona. So the artificial intelligence journey, milestones, and the way ahead. As you can see, here you see the rise and fall of AI around 1970s. I mean, it has its ups and downs, it has its winters also. 1975, around that time, a little from before that to a little after that, there was a winter in AI research. Then again in the 1990s, late 80s, 90s. But now we are rising, and we are, as you can see, in 2000, that graph ends in 2017, and from it has still risen. In 2025, it's still higher. It's more on the green line. But then imagine that 2017 is 2025. Now, from there, where will we go? We don't know yet. It could actually go in the green trajectory, where it becomes quite scary. Excitement fades, the orange one, or the red, the bubble bursts. There are people who believe in all three of those possibilities. So we have to see. But that it is becoming more and more scary is indeed a fact. So let's see where it started. The thought of thinking machines that could think for itself, started way back, you see, in the 1940s, when Alan Turing was already thinking of these things. Okay? And in 1950, he designed the Turing test, which is a test of machines' ability to exhibit intelligent behavior. Okay? And that Turing test has proved to be really difficult to crack. The Turing test was essentially that there's a computer and a human, and there's an interrogator, let's say, in another room. And there is a written conversation happening between the interrogator in one room, and either the computer or the human will answer, but nobody can see, the interrogator cannot see who's answering, and it's a written communication, okay? And the task is the interrogator has to determine which of the two is human, whether the response that has come in from a human or a computer. And if the computer can fool the interrogator sufficient number of times into believing that the human has responded, then the Turing test would have been passed. The computer can be called to be truly artificially intelligent. Okay, and it has proved to be really difficult to pass. Sort of a Turing test was passed way back in 2014, when the computer fooled 33% of the judges into believing that the software is actually I think a 13-year-old boy. Okay, but that was not really the Turing test which was passed. In fact, it was passed only in 2025. We'll come to that. But then the developments happened. Many things happened. 52, Samuel Checkers program, Checkers playing program. 1956 was a watershed moment in the Dartmouth summer research project on AI. The term AI got coined. McCarthy was one of the main persons behind that. 58, you see Arthur Samuel, he coined the term machine learning. And Rosenblatt developed perceptron, which was a simple computing model. You see the neuron over there, which is getting certain inputs from various input channels. And each input channel has a weight. So it does a weighted averaging and then applies some function on the weighted average, and that's the output which goes. And that, because it was able to, design the boundaries between classes, so it could do classification problems, and it was thought that this is one of the best things which has happened. A lot of interest peaked. The point here was those weights, because the inputs are inputs. That's from the data which is coming. But the weights, what should the weights be? And nobody fixed those weights. Okay? So that was learned by the system. By looking at the inputs and the outputs, it was able to learn, and there were algorithms for learning those weights. And since it was learning happening, the system automatically derived those W's. So this was a first learning aspect. Machine learning was coming into picture now. So this happened, development continued. You can see the NLP program student was developed in MIT in 64. Then there were first expert system, the Dendral, which was assisting the organic chemists. Okay, and the first chatbot, Eliza. So a lot of things happened. The Shaky, the first mobile intelligent robot, nothing compared to what it is today, but it was a breakthrough at that time. 69, the first ICDMAI happened, International Joint Conference on AI. And around that time, the development started stalling, because it was proved that the perceptron, which I showed 2 slides back, it could not solve a very simple problem. Okay, so the interest, but that was not the only reason that the interest waned. There were other things, other promises which could not be kept. The systems were not becoming that intelligent. So the interest went down, funding went down, and the first winter set in. So that was sort of the first winter, as you can see in the right-hand side bottom. Then it re-emerged in the mid-1980s, because again, now Rumelhart, Hinton, Williams, they came up with this backpropagation algorithm and a multi-layered perceptron. Earlier, it was only a single layer of those neurons. And it was initially thought that that single layer of neurons would solve all problems. Then it was realized that a very simple problem could not be solved. And that was, the solution was in multi-layer perceptron. The problem was that nobody knew how to, again, find out the weights on those connections. That had to be learned. And even today the transformers or whatever we are using, it's all based on this backpropagation of errors. You give an input, you get the output, you know what the correct output is because you have training data, and then you see what is the error and you start changing the weights a little bit, of course mathematically defined ways in which you change the weights so that the error will go down. That is essentially the principle, and that is what all our neural networks, even today, they are being. A pair of 6 games, there were 2 such 6-game matches. Okay, the first match of 6 games in 1996 in Philadelphia, which Kasparov won 4-2, right? But at least in 2 cases, Kasparov lost, but in 4 cases Kasparov won. So the match was won by Kasparov, but it was already shown that a machine could defeat Kasparov. And there was a rematch in 1997, where Deep Blue, it won 3.5 to 2.5. First, as you can see, Kasparov won, then Deep Blue, then there were 3 draws, and then Deep Blue won. So 3.5 to 2.5. So first computer program to defeat the champion. And the interest also went up and up and up. And 2009 we see GPUs came in, okay, and GPUs were a major breakthrough because the technology was ready, the algorithms were there, but the algorithmic technology was ready, but the hardware was not ready. So with GPUs, a lot of things could be achieved. 2012 AlexNet, the ImageNet competition was won, and interest in deep learning was at an all-time high. CNNs by Hinton again, and others. 2013 reinforcement learning came in. 2014 the generative adversarial networks, they came, where data could be generated by the system, and it went up and up. Okay. So in 2016, we had the Sophia, the humanoid robot by a Hong Kong-based company. And if you recall, a couple of years back, 3 years back maybe, Sophia had come to Kolkata also and had interacted with us. Okay, I was there in Vishwamangala auditorium at that time. 2017, the diffusion model, and the major breakthrough in 2017 was the concept of transformers. Okay, and what was it on? It was based on attention. You have to, attention is all you need. That was the main thing. Okay, the animal didn't cross the street because it was too tired. That the animal, it refers to animal and not to street. Okay, because it could have referred to street also, but it refers to animal. Those things got built into the system. Okay, and large language models came up. 18 to 23. You see all these GPTs, ChatGPT, etc. And Bengio, Hinton, and Bekun, they won the Turing Award. DALL-E came in, which could generate images. So computers were coming in into the domain of human beings. We could create. Now computers were creating. Okay. And 24. The Physics Nobel Prize went to Hupfield and Hinton. But again, as I said, from 70s he's working in this neural networks, okay? So, it just shows that things don't happen overnight. One has to just persevere, keep on it, okay? And have faith and believe. Continue. And we have also the Chemistry Nobel Prize, which came to David Baker for AI-based methods for designing new proteins, and Hassabis and Jumper for AlphaFold, the AI algorithm that accurately predicts protein structures. So, the Nobel Prize coming to AI researchers, that's a major boost for AI research, right? And in 2025, as I said, the ChatGPT 4.5, it passed the Turing test in a San Diego study. The participants held simultaneous 5-minute text conversation with a human and a Gen AI model, and they had to guess which one was the AI. GPT 4.5 model was so convincing that it was judged to be human 73% of the time, so much more than what Turing had designed. And so the Turing test was actually passed in 25. I was also, whenever, these days it's very difficult to stop yourself from going to ChatGPT whenever we need anything. And now we've stopped even probably starting anything from scratch. Whatever ChatGPT gives us is that's where we start from. Hopefully, some people have they don't even check what ChatGPT has given. But I was just giving ChatGPT how to give an interesting keynote lecture. Okay, and it gave me a very long list of very good points, very relevant points. It also gave me some additional tips. Dress appropriately, okay, and use humor wisely. Of course, very nice, very good tips. And of course, we know that we can prompt and get smaller answers, better answers. What we are really looking for, if that is missed, we can prompt. Prompt engineering is a different area again. And why the research moved in spurts is, as I said, the theory was ready, but the hardware technology was not yet available, and storage was expensive, computing speed was limited. As soon as that was overcome, there's no stopping now of AI research. So a lot of computing now, everybody has, even it's so nice to listen today that the Society for Data Science has committed 100 hours of GPU time to St. Xavier's for starting the data science course, because that is what students will need very much. So, and we all know AI is everywhere. You look at agriculture, healthcare, smart cities, wherever, it is now everywhere. And so I will not go into the, because I've almost reached the end of my time, but agriculture now, a lot of applications for sustainable agriculture, and you cannot avoid these things anymore. In e-commerce, in urban planning, weather prediction, a lot of AI is now getting applied in policy, right? And in healthcare, because I personally work in healthcare, and what we've been doing for applying AI to healthcare is I've been working in a small particular space of microRNAs. That's a lot of my work has dealt with microRNAs. And what are microRNAs? You see, it's an RNA molecule. We know the RNA, and it's micro, meaning it's small, right? So these small molecules, small RNA molecules, essentially what they do is they go and interfere with production of proteins inside the cells. So cells produce proteins through different mechanisms, and the microRNA will go and interfere with the protein production at a very fine level. It is not a bulk level that it is acting, but at a very fine-tuning level, it does this. And what happens is, suppose, you see cells are dividing, right? And in every such cellular process, there are multiple proteins which are involved. So, let's say cells are dividing, but then if cells are dividing, then cells need to be killed also, right? Because otherwise there will be a lot of growth of cells. So, cell killing is a normal process, and there are proteins which are involved in cell killing. And those are called apoptotic proteins. Now, we work with some proteins which became active due to certain factors at a particular time point in the life cycle of the organism, and it went and interfered with production of such an apoptotic protein. Okay. So what happens is, essentially the protein, the target protein, is unable to function. Now cells are dividing, but a protein which was responsible for killing cells becomes unable to function, so there's nothing to kill the cells. So cells will proliferate. And what is that? That is essentially cancer. Now, not only cancer, but in many diseases it is found that microRNAs are very heavily implicated. Their levels, the normal levels of microRNAs have either gone up or gone down in the disease states. So it was very important when I started working in microRNAs actually, and I must also confess that I did not choose biology because I was terrified of biology in my school days. I had to remember so much in biology that the first option I got of leaving biology, I left it. But then what happened is, when I was a young faculty, a student joined me who had a biology background, and he convinced me that the pattern recognition algorithms that we were developing, essentially we were developing classification, clustering, feature selection algorithms using something called genetic algorithms. There's another area of research, the meta-heuristic optimization techniques. So he convinced me that the algorithms that we were developing had great applications in biology. So for 1.5 years, he taught me biology, I taught him computer science. And that's how it went. I was a very bad student because every day he would teach and next day I would forget. Then he would reteach. And that went on for some time because it takes time, to stick. And then I learned a little bit of biology with which I was able to understand what I was doing. Okay, what applications I was doing. And that is also something I would like to share with my younger friends, that it is extremely important to understand the domain of what you are doing. I have seen many young students who are doing very great applying great algorithms to biology, but when I ask, okay, you've taken this matrix, what does that particular value that in that particular row and particular column mean? Person is lost. So it is very important not only to develop new algorithms, but don't take it just like a black box. Understand the domain also, because the knowledge of the domain will also help you in developing algorithms. So once we understand the biology, in fact, we developed a new measure for computing the distance between two genes, for example, based on their some data. What is the distance between two genes? Because by distance we often mean the Euclidean distance, right? Okay, just from one point to another point, Euclidean distance. But how to measure gene distance between two genes was actually motivated by the biology behind it. So anyhow, I was working a lot in microRNAs, but the work that actually became very important was we discovered computationally some microRNA markers for two cancer types. One was breast cancer and one was colon cancer. And that came up through our computational methods. We were not really knowing the biology, what was happening, but then some marker was validated independently by another laboratory. They were not looking at our paper, but independently they also came up with those same markers, but through biological experiments. We were only doing computational experiments. So other than this work, we've also done a lot of work in drug design, for example, because if you think of drug design, drugs are essentially small molecules which are targeting, most of the drugs, small molecules which are targeting some proteins which are misbehaving. These proteins inside the cell, it could be our own protein, it could be a protein of the pathogen, but it is responsible, it's crucial for the disease happening. So can you design a small molecule which will go and bind into this protein, sit with this protein, effectively neutralizing this harmful action? So that is what drug design is. And if you think deeper, it's essentially an optimization problem, constrained optimization problem. We posed it as a multi-objective constrained optimization problem, and so we cannot say we've solved it, but we came up with one method of drug design. Okay, that's a very difficult area though. So these were some of the things that we've been doing in our lab. But then 10 years of administration has taken me away. I'm trying to now get back into research, and my students are, I think, furious because now every day I'm calling them and sitting with them. So they are also, earlier it was easier. But what is the state of the art now? What are we doing now? We are focusing a lot on agentic AI, not we meaning my group, but in general in the AI community. Very specialized AI models which are fine-tuned for particular domains. In India in particular, it is very difficult for us to train from scratch. Okay, we don't have that resources, at least most.
Firstly, I've only done what I've done and continue to do because it's what I've been called to do, but I don't do it for any other purpose bigger than it's the right thing to do at this time. I want to begin by sharing a story. When we hear the word Afghanistan, of course, I would predict that you also know that Afghanistan, perspective of my birth country of Afghanistan, where education levels are low. Literacy in technology is pretty much non-existent, with the exception of a handful of men. And now if they're embedded with the powerful men, of course they're utilized for their benefit and their advantage. And so what it has done is the inequality of not having proper knowledge in this sector and in this field is leaving millions of people blind. Blind to the fact that AI is, to understand what AI is, to understand what technological advancement is, not even having the ability to use it, but their lives and their futures being shaped by something that they have absolutely no access to or no knowledge of. Imagine being, I guess my response to your question is, imagine yourself being a citizen, and particularly a woman or a young girl in Afghanistan, being unjustly driven by a group of people who have access to that information. So inequality in that sense, I think, brings it down to the very basic human level of how we're seeing this. But at the end of the day, again, I'm a professor, but I'm not educated in what this technology is capable of. Just listening to the previous lecture, I've learned so much. And I just question and wonder how much of this information is available to the public at large globally. And so the inequality is apparent in front of our eyes all over.
Any other question? Yes, madam, you correctly said that human ethical values should shape AI, but the ethical values are also dependent on the culture, and culture varies from region to region. So how people from one region developing an AI system can incorporate the culture and ethical values around the world?
That's a $1 million question that you're asking, and that just doesn't apply to AI and technology, but that's also part of governance, that's part of development, that's part of the aid package. Having witnessed the fall of my country, of the 20-year false promise that was given by the global community, we're going to help develop Afghanistan to go from a war-torn country with absolutely no infrastructure left in early 2000 or 2001 after 9/11 attacks, to handing over the country back to the very people who were considered to be the perpetrators of the mess, is beyond reason and beyond understanding to a human being like myself, where ethics, even from a political point of view, was that and is that an ethical decision? So I think in the end, you're absolutely right. Ethics are bound by one's belief systems, both from a spiritual perspective, but also a cultural perspective. But I think, in the end, one of all of humanity's ethics systems is do no harm. If you can predict and perceive that you creating a system might harm a community, a people, a region, a country, don't do it. And if we can instill that through our education systems into creating ethical, moral beings, I think we will have done our job. But obviously we're not proving ourselves. We've proven to ourselves globally that unfortunately our education systems across the globe have not created and not produced very ethical leaders, unfortunately.
I think in offline. So
can you take the offline
inconvenience regretted. So ma'am started saying that I'm not an AI person. But we do not need a Google Translator or an NLP technique to admit that the last 45 minutes has been, you know what, ma'am? Rangina. If you just translate it, in Bengali it means colorful. And to add to that, Ashish means blessing. The last 45 minutes, ICDMAI has been colorfully blessed. Big round of applause. It enchanted the role of humanity, blended with AI tools and support. to overcome the barriers of colonialism in education. Thank you, ma'am. As always, we'll give the honors after the session. To felicitate ma'am, it's my proud pleasure to welcome Mr. Xavier, sir, Industry Chair, ICDMAI 2036. Put your hands together to welcome Mr. Xavier, sir. Let's capture the moment. It's a colorful presentation. To thank our respected session chair, Professor Ashish Chatterjee sir. To felicitate Ashish Chatterjee sir, I request Professor John Tushan sir, as Sporty's Executive Committee member, to please come forward and do the honors. Let us welcome Professor John Tushan sir. The applause are not getting loud. I understand people are waiting for their appetite. Fantastic moment. Thank you, ma'am. Thank you, sir. Thank you to all the dignitaries on and off the stage. Moving on, very quick. The train is running 40 minutes late. Before that, we have, once I request the session chair to come in. Sanya, let's make it fast. Ma'am, it's our proud privilege to welcome Professor Catherine Leonard, ma'am, Interim Vice President Academic Affairs and Dean, Occidental College, USA. To session the chair, we have Dr. Abhishek Hodikar, sir. We gratify his presence over here. It gives me pleasure to welcome Professor Odhikari, a distinguished professor and head of the
এরপরে আমরা চলে গেলাম লাঞ্চের জন্য। লাঞ্চের কুপন অলরেডি দেওয়াই ছিল। শীতের রোদ্দুর, আফটার নলেজ গ্যাদার we are going for taking lunch. লাঞ্চটা দেওয়া হচ্ছিল সেন্ট জেভিয়ার্সের বাস্কেটবল যে গ্রাউন্ড রয়েছে ওখানে। চারিদিকটা এত সুন্দর লাগছে, ওই উপরে দেখুন বোগেনভিলিয়াগুলো এত সুন্দরভাবে রয়েছে, অসাধারণ। আমরা চলে এসেছি লাঞ্চের লাইনে। আর এখন ক্যামেরা করবো না। লাঞ্চ হয়ে গেল, তারপর আমরা একটু ফটো সেশন করে নিলাম। স্যার, আমি শাইনি। তারপরে স্যার বললেন যে স্যারের একটা উত্তম কুমারের মতো ছবি চাই, ছবি তুলে দিলাম। কালকে রয়েছে সেন্ট জেভিয়ার্সের ওখানে ম্যারাথন। দুপুরবেলার মিটে রোদ্দুরে সেন্ট জেভিয়ার্সের কলেজ, সেন্ট জেভিয়ার্স ইউনিভার্সিটি, তার সাথে এর ব্যাপার একসাথে দুর্দান্ত। আপনারা কারা কারা গেছিলেন আজকে অবশ্যই কমেন্ট করবেন। এখন চলছে কলকাতাতে 9 থেকে 11 জানুয়ারি 2026, আগামীকাল শেষ হয়ে যাবে প্রোগ্রাম। এইটা কিন্তু খুব সুন্দর ছিল জানেন, হিউম্যান ইন্টেলিজেন্স জাস্ট কামিং টু আর্টিফিশিয়াল ইন্টেলিজেন্স, এআই। এবারে আমরা একটা ছবি নেব ডক্টর কনক প্রিয় বসুর সাথে। উনি হচ্ছেন আজকের অনুষ্ঠানের মেইন প্রেসিডেন্ট। আপনারা সাথে থাকুন, ভালো থাকুন, আনন্দে থাকুন এবং অবশ্যই সুস্থ থাকুন।